Welcome back to Machina Zone, the channel where machines, history, and human ingenuity come together. Here, we celebrate the art of making, from the mighty forests to the factories that shape our modern world. The lumber industry has long been at the heart of human progress. From the early sawmills powered by water wheels to today's computer-controlled giants, wood has built our homes, our bridges, and our cities. And few names carry as much weight in this story as West Fraser, one of the world's leading wood products companies. Today, we'll take you on a remarkable journey. We'll see how timber is harvested with precision, processed with advanced machinery, and transformed into engineered wood products of unmatched strength. Every log tells a story, and every machine plays its part. So let's begin, deep in the forest, where the cycle of industry starts. Every journey of wood begins long before a tree is felled. It starts with harvest planning, a careful balance between economics, ecology, and sustainability. Crews map the forest, mark the zones, and design access routes that protect soil and water. Nothing is left to chance. Next comes site preparation. Roads are cleared, temporary bridges are built, and the land is readied so that heavy equipment can move safely without damaging the forest floor. Then, the moment of truth, felling. Skilled operators, often using powerful harvesters and chainsaws, bring down trees with remarkable control, ensuring safety and minimizing waste. Next comes site preparation. Roads are cleared, temporary bridges are built, and the land is readied so that heavy equipment can move safely without damaging the forest floor. Then, the moment of truth. Felling. Skilled operators, often using powerful harvesters and chainsaws, bring down trees with remarkable control, ensuring safety and minimizing waste. Next comes site preparation. Roads are cleared, temporary bridges are built, and the land is readied so that heavy equipment can move safely without damaging the forest floor. Then, the moment of truth. Felling. Skilled operators, often using powerful harvesters and chainsaws, bring down trees with remarkable control, ensuring safety and minimizing waste. From the silence of the woods to the rumble of machines, this is where the story of lumber begins. And what comes next is the art of turning raw logs into precision-engineered materials inside the mill. From here, the logs are lowered into massive vats of hot water or steam. This stage is both ancient and modern. For centuries, woodworkers have steamed timber to bend it into ships, barrels, and furniture. The principle is timeless. Heat softens the lignin inside the wood, making it pliable. Trucks arrive heavy with timber, their loads groaning under the weight of freshly cut logs. Giant cranes swing into action, their steel claws lifting each log as if it were a matchstick. The scale is staggering, yet every movement is controlled with finesse. Here, nothing is left to chance. Advanced scanners measure the length, diameter, and quality of every log. In earlier days, men judged timber by eye, tapping with axes and feeling with their hands. Today, lasers and sensors perform this task with unerring accuracy. The logs are then cut into precise lengths, bucked to maximize yield for veneer production. Each cut is more than mechanical, it is strategic. A log too long may not fit the lathe. Too short, and valuable material is lost. The bucking station is where nature's irregularity first meets industrial discipline. From here, the logs are lowered into massive vats of hot water or steam. This stage is both ancient and modern. For centuries, woodworkers have steamed timber to bend it into ships, barrels, and furniture. The principle is timeless. Heat softens the lignin inside the wood, making it pliable. Inside these vats, water heated to near boiling seeps into the logs. The warmth penetrates deep into the grain, loosening fibers and preparing them for peeling. Without this stage, veneers would splinter and tear. Imagine the log as a roll of paper, tightly wound. The vat is what loosens that roll, making it ready to unspool smoothly. Hours later, the logs emerge warm, heavy with moisture, and perfectly prepared for the delicate cut of the lathe. Next comes roundup, or debarking. Machines fitted with rotating heads and hardened steel teeth tear away the rough bark. The log spins violently as sharp arms press against it, peeling away the outer layer. Bark may seem useless, but in the mill, nothing is wasted. Conveyors carry it away to fuel boilers, where it will generate heat and power. What once shielded the tree in the forest now drives the engines of industry.
Bark may seem useless, but in the mill, nothing is wasted. Conveyors carry it away to fuel boilers, where it will generate heat and power. What once shielded the tree in the forest now drives the engines of industry.
The log, now softened and cleaned, is placed onto the spindleless lathe. This machine is one of the marvels of modern lumber production. Picture a giant pencil sharpener. The log rotates with incredible speed while a long knife slices into it, peeling away veneer in a continuous sheet. The wood unrolls like a ribbon, sometimes hundreds of feet long, thin, and even. Every fraction of a millimeter matters. Veneer that is too thick will waste material, too thin, and it will lose strength. Computers monitor blade pressure, adjusting every instant to maintain exact thickness. The sight is almost hypnotic, a tree unspooling into delicate layers, transformed from solid to sheet in seconds. These veneers are the foundation of laminated veneer lumber, the engineered product that will soon be pressed into beams of immense strength. The endless ribbon of veneer moves forward to the clipper. Here, sharp blades cut sheets into uniform sizes. The machine works rhythmically, slicing with a snap like a giant pair of scissors. Defective sections are trimmed away. Knots, splits, and discolored patches are removed, ensuring only the best veneer continues onward. Each cut is exact, down to fractions of an inch. The sheets emerge neat and orderly, stacked for the next stage. At the stacker, veneer sheets are gathered into piles. Automated arms lift and lay them carefully, creating stacks that can be easily transported through the line. This may seem mundane, but order is vital. Veneer must stay flat, aligned, and clean. A misaligned stack could jam the press later or create weakness in the finished beam. Machines handle the weight, but human eyes oversee the process, ensuring everything remains in perfect order. Before drying, the sheets undergo random pulling. Workers, assisted by scanners, inspect each sheet, pulling out those with defects too severe to continue. Some may have splits, others might be too thin. But nothing is discarded. Imperfect sheets are rerouted, chipped into pulp or fuel, destined for other useful purposes. This stage ensures that only strong, consistent veneers enter the critical stages ahead. Rejected wood and offcuts arrive at the chipper. With a roar, spinning blades shred the material into small chips. These chips will not become beams, but they will find new life as raw material for paper mills or as biomass fuel. In earlier times, scraps piled up as waste. But modern mills respect the tree fully, using every part. The chipper is the embodiment of that philosophy. Nothing is wasted, everything has a place. Some logs and sheets need trimming at the pointer donga. Here, ends are shaped into points, making them easier to feed into continuous machines like dryers and presses. This might seem like a small detail, but in a mill where thousands of sheets move daily, smooth feeding saves hours of downtime. Efficiency often lies in these quiet, unseen steps. The mill is not just a consumer of energy, it is a producer. At the hog fuel system, bark, sawdust, and chips are burned in massive boilers. The heat produces steam, which powers turbines and heats the dryers. This closed-loop system is sustainable, reducing reliance on outside power and cutting waste. In many ways, it mirrors the old logging camps, where every scrap of wood was thrown into the stove to keep men warm. Only now, the scale is immense, powering entire industrial lines with the tree's own byproducts. The veneer sheets now enter the dryer, long tunnels where hot air rushes across moving conveyors. The goal is to reduce moisture content to a precise level. Too wet, and glue will fail in the press. Too dry, and the sheets may crack. The balance is delicate but vital. Sensors monitor conditions constantly, adjusting temperature and airflow. As the sheets emerge, they are warm to the touch, light, and stable. They are now ready for the next test, sorting by density and moisture. Density and moisture sorting. Science meets wood. At this stage, technology takes center stage. Veneer sheets pass through scanners that measure density and moisture content. High-frequency sensors peer inside the wood, detecting even subtle variations. Sheets with higher density are grouped together, destined for beams that will carry the heaviest loads. Others are sorted for lighter applications. Every piece has a role. Every sheet is directed where it will perform best. This scientific sorting ensures that when builders place an LVL beam into a house or bridge, they know exactly what it will bear and how it will perform, with no surprises. Now comes the heart of the process, the press. Here, thin sheets of veneer, each coated with adhesive, are stacked layer upon layer. Unlike plywood, where grains cross each other, LVL is stacked with grains running in the same direction. This alignment gives immense strength, creating beams that resist bending and twisting. The stacked veneers are loaded into enormous hydraulic presses. Heat and pressure combine, forcing glue into every fiber and bonding the sheets into a single solid billet. The press roars, steel plates close, and after minutes of controlled heat, the billet emerges, a beam longer, straighter, and stronger than natural wood could ever be. This is the moment of transformation. Nature's gift becomes engineered strength. ready to support homes, schools, and bridges. The billets are carried to precision saws for beam and header production. Guided by lasers, machines cut the beams into exact lengths and widths. Some will become headers above windows and doors, others will span entire floors. Every cut is recorded, every piece tagged. Builders demand reliability, and this is where that reliability is guaranteed. Straight, strong, and consistent. Each beam is identical to the next, an engineer's dream. With strength assured, beams move to paper wrapping and tagging. Wrapped in protective paper, they are shielded from moisture during transport. Each piece receives a tag, marking its dimensions, grade, and certification. This is transparency in action. From the forest to the builder's hands, every beam carries its identity, a record of the care and precision invested in it. At last, the finished products are loaded onto trucks and rail cars. They leave the mill bound for construction sites across North America and beyond. From a seed in the forest to a beam in a home, the journey is complete. What began as raw nature has become engineered reliability, ready to hold the weight of lives, dreams, and generations.